This is the amplifier I'm using. It's I always forget who it's made by, but if you literally look up 2400-1.0W, which is what it is, it will give you the model number. So what you're looking at is your end connectors. This is an end coupler, and this is the amplifier itself. A red light comes on when it has power, and it turns green when it has a signal. So it can drop out if the signal coming into the whole system is not strong enough. But essentially this is the amplifier itself. It's not light. That's kind of one of its drawbacks. It's also pretty large. So we're looking at it here, and you're looking at from probably in injector to in injector, it's 9 inches. So it's not exactly tiny. But on the contrary, this is made for high cycle work. 3 1/4 inches. So that means that you can leave this on for years without problems, and that's what it's designed to do. Now, we're not running our bags for years, so that's not really a problem. But the heat dissipation on this is pretty good. The fins are pretty deep, so you can see that it's actually going to dissipate a lot of heat. The board inside here is actually very small. It's only about as deep as the actual LED is. So that means that all of this metal is simply for heat dissipation, which is huge with amplifiers because people don't realize how much power is actually wasted because they create so much heat. But 1 watt, it gets pretty warm. So when I see these other tiny things, I'm looking at, well, there's no heat fins, there's no heat dispersion, and it's going to get hot, and it's probably going to burn itself out. So that's what makes these, you know, gives them longevity, is the heat dissipation. Now you're wondering what the fuck this thing is over here. This is actually how it gets its power. It's just a DC injector. It's like any other, I don't know if you know what a DC injector is, but essentially this needs power, and what they'll do, instead of running power up to this, they'll put the amplifier at the top of the roof, and this will have the shortest run to the antenna possible. So, I don't know, 1.5 feet, 2 feet maybe, and then they'll run the signal all the way back down to wherever. So this will be at the bottom, and your video transmission system or whatever it is going to come out and go into here. This is going to send power, DC power, all the way down the line, which is going to power up this guy here. So you do need a DC injector. There's ways of making them. I haven't really looked at it because I have one already, but I just modified mine. I took out the 2.5 millimeter connector because it frankly sucked, and I have a buck converter that goes in my bag that regulates the power to 9 volts, which is what this is, and then I just connect this proprietary connector so I don't screw it up. This is a Dean's connector. We use them all the time in RC applications. It could go directly into a battery, but I'd probably blow it up because this only wants 9 volts. But it works very well. And the thing is, I decided to go with this rather than a cheaper solution because everything is regulated, but we need to kind of make sure we're doing our part to make sure it stays regulated. You can buy these cheap Chinese shit transmitters or amplifiers, but you don't know what the RF spray looks like. You could be just blasting 4.8 gigahertz or 900 megahertz or 600 megahertz because it's a shitty resonator inside and something's not working properly. This company is Teletronics. Teletronics. This company is known for making some of the best Wi-Fi amps possible, and they make really good stuff, very well regulated on their own. They're not going to spray into other stuff, and that's really important when you've got, you know, 8 wires in a bag. You don't want to be stepping on your own stuff. So the only problem is, because it is high power, and of course it's super high frequency up in the microwave, but microwave is once you get to like 10 megahertz anyway. But because that's so high, if you get any cables near it, you're going to hear it, and that's kind of a problem. So it works well outside of the bag, and I have used it in a bag because I needed to send good usable scratch track to a long distance on a camera that was roaming about 300-400 feet away. So it worked, and the battery, I think the equivalent of an NP1, I was getting 4 hours off of the system, and that's just this. A 4.5 amp hour 12 volt battery was giving me 4 hours. Well, I guess that's not equivalent to MP1. I lied. So anyway, sorry, it's so just verbose and long-winded, but this is the system. It's not in that light. Like I said, it's not small, but if you can find a way to mount it in your bag or underneath stuff, then it'll work really, really well, and you just got to carry extra batteries with you. RF amplification it's not cheap, and it's not power efficient. It's not made to be. It's supposed to be super high power, so that's the whole point of it. But something else I was going to say, I can't remember. Oh, the price of these. Go to eBay, Teletronics, 1 watt Wi-Fi, and I think you can find them as low as $90, but you know, look for deals. I bought 5 of these for like $100, but they didn't come with DC injectors, so they're completely useless. So then you have to go buy a DC injector, which is whatever someone wants to charge for it. But if you go check out some electronics forums, they'll probably give you a schematic how to make a DC injector. They're not very hard. It's literally just a couple of transistors, capacitors, and I think a couple resistors. But I mean, if you've got the time, then you can do it. This doesn't really create any power, so it just is in something that's bulky to keep it safe. These end connectors, you know, with enough time, you can remove them and put on SMA. You know, it's not very difficult to do. It's just time consuming because you have to take all of this apart, then you have to unsolder the center conductor off the board before you lift the board off of this. So it's just time. So hope that answers all your questions.